What's up everybody and welcome to a new video. And in this video we're going to go over my notes for zero-based indexing in Python. And here the first note is about those two questions here. So here the first question is why does the index start at 0? So for example, here we have a list containing A, B, C, D, E, and now let's say that we want to get here this A. So to do that we would need to say list and then brackets and then here a 0. So this would then get us an A. And then here the question is, why does this first element of this list here have the index 0 and not index 1? So that's the first question. And then the second question is in slice notation, why is the start included and the end excluded? So for example, here in our list, let's say that we want to get this slice here, so the B and the C. To do that, we would need to say list and then brackets, and then here in the slice notation we would need to first specify the start, so that would be then here a 1, and then we have to specify the end, so in this case then we have to use here a 3. So this then gives us a B and a C, and then here the question is, why do we have to use here a 3, which is actually the index of this D here? So in other words, why is the end here not included in our slice? And now to answer these questions, I have prepared here these slides. So here we have a list containing A, B, C, D, E. And now if you wanted to access an individual element of that list, then you would need indices. And here an intuitive thing to do would be to start those indices at 1. So for now, let's just work with this 1-based index here. And then next, if you would wanted to access a slice of this list here, then you would need slice notation where you specify a start and an end. And here you basically have 4 options available. So you could include the start and the end, you could exclude the start and the end, or you could have a mixture of both where you include the start and exclude the end, or the other way around where you exclude the start and include the end. And now to decide which one of these 4 approaches to pick, we're going to compare them based on 2 specific use cases. So the first use case is to create a full slice, and the second use case is to create an empty slice. And then we're also going to compare them based on 2 conditions. So the first condition should be that the length of the slice is equal to the end minus the start. And then the second condition is that 2 adjacent slices should then create the whole list again. So now let's first compare those 4 approaches here based on how we would create a full slice. So when the start and end are included, then the notation would look like this, where we start at a 1 and end at a 5. Then when the start and end are excluded, then the notation would look like this, where we start at a 0 and end at a 6. Then here when the start is included and the end is excluded, then the notation would look like this, where we start at a 1 and end at a 6. And then lastly here when the start where the start is excluded and the end is included, then the notation would look like this, where we start at 0 and then end at 5. And I think out of those 4 approaches, it's pretty clear that this one here looks the best, because it simply contains here the first and the last index here of our list. So now let's compare those 4 approaches based on the second use case, which was to create an empty slice. And let's say that we want to start that slice here at index 1. So in that case, for this first approach here, the notation would look like this, where we start at 1 and then end at 0. Then for the second approach, we would start at 0 and end at 1. For the third approach, we would start at 1 and also end at 1. And then here for this last approach, we would start at 0 and then end at 0. And here out of those 4 approaches, you maybe could argue that this one here looks the best, because the start is actually before the end is actually before the start. So therefore it makes sense that the slice is empty. However, there's a problem with this approach here. Namely here we have a 0. And since we are using 1-based indexing for now, there's actually no index with 0. So therefore then you could say that this approach here is the best, because it's the only one that doesn't contain a 0. And additionally here for this approach, the slice starts at 1 and also ends at 1. So therefore it's not really a slice, because it doesn't cover any ground. So for example, an analogy would be a train going from train station 1 to train station 1. So this also doesn't cover any ground. So therefore it makes sense that this slice here would be empty. So for this use case here, it's maybe not so clear which approach here is the winner. So let's simply give them both here a point. So then let's now compare those four approaches based on this first condition here, which was that the length of the slice should be equal to the end minus the start. And the specific example that we're going to look at is a full slice. So here are these full slices. So then here for the first approach, we would calculate 5 minus 1, which is 4. Then for the second approach, we would calculate 6 minus 0, which is 6. For this third approach, we would calculate 6 minus 1, which is 5. And then for this last approach, we would calculate 5 minus 0, which is 5. So as you can see, in this case here, only those last two approaches actually fulfill here this condition. So now let's compare those four approaches here based on this second condition, which was that adjacent slices should again create here the whole list. And the example that we're going to look at is when I equals 3. So then in this case here, for this first approach, this first slice here would go from the start until position 3. So that this would then look like this, where we have ABC, because the end is included. So therefore here the C would be included. And then here the second slice would go from position 3 until the end. So then this slice would look like this, where we have CDE. And that's because the end is included. So again, the C here would be included. So therefore then we have here those two slices, ABC and CDE. So those are not adjacent because they both contain here this C. Then here for the second approach, the slices would look like this, AB and DE. So here the C is missing. So those are also not adjacent slices. Then here for approach 3, the slices would look like this, where we have AB and then CDE. So those are adjacent slices. And then here for this last approach, the slices would look like this, where we have ABC and then DE. So again, here we have adjacent slices. So as you can see, only those last two approaches here actually fulfill this condition. So as you can see, out of those four approaches here, the third approach has here, so to say, the most points. So it makes sense to include the start and exclude the end for slice notation. So now, given that we use this approach for slice notation, let's now compare zero-based indexing with one-based indexing. And we're going to compare them based on a specific use case, namely accessing the first n elements. And the specific example that we're going to look at is when n equals 3. So in this case, then here for zero-based indexing, if you want to access the first three elements, so A, B, C, then we have to use here this 3 for the end in our slice notation. So then the notation would look like this, where we use here this 3. And then for one-based indexing, we would need to use here this 4. So then in our notation, we could then, for example, say then here 3 plus 1. And since we want to get the first three elements, this notation here looks a little bit cleaner. So therefore then we're gonna pick zero-based indexing over one-based indexing. So in conclusion, as you can see, there's not really a technical reason for using zero-based indexing or a slicing notation where the start is included and the end is excluded. It just results in a syntax here that looks a little bit cleaner. And it's also not a definitive answer because there are, for example, also programming languages that actually use one-based indexing. So hopefully these slides helped in answering those two questions here. So therefore then, let's now get to this last point, which are some mnemonics for remembering how indexing and slicing works. So let's start with indexing. So here I've written down that the zero-based index tells us how many elements are before the index. So to show that, I've prepared here this list. So here we have the letters A, B, C, D, E, F, G, H. And now let's say, for example, that we wanted to access here this D. So therefore then, to use this mnemonic, we simply need to count how many elements are before that. So there are 3. So therefore then, if we say then here list brackets 3, then here we get this D. And we can also do it the other way around. So for example, if I say here list and then brackets 5, so then we can check which element this is here. Therefore simply need to count 5 elements. So those would be then here those 5 elements. So therefore then we should get here this F. So now if I run this, then you can see that we get here this F. So this is the first mnemonic. Then the next mnemonic is for slicing. And here the start simply makes use of this rule here. So the start also tells us how many elements are before the index. And then for the end, you simply need to calculate the start plus the length. So to show that, let's again use here this list. And here, let's now say that we want to create a slice going from B to E. So here, as we can see, there's one element before this slice here starts. So the index that we first have to use for the start is the 1. And then for the end, we simply need to calculate the start plus the length. So 1 plus, in this case here, then 4. So the end is then here at 5. So now if I run this, then we get here the slice B, C, D, E. And again, this also works the other way around. So if I say here, for example, or if I create here, for example, a slice going from 3 to 7, then if we want to check which elements that are, then we have to first check here the start. So there are 3 elements before that. So here are 3 elements. So the slice is going to start here at this D. And then here, as we can see, the length of the slice is going to be 4. So therefore then we need to include here 4 elements. So this slice here should include the elements from D to G. So now if I run this, then you can see that we get here D, E, F, G. Okay, so those are the 2 mnemonics that I have here. And with that now we've covered all my notes with respect to zero-based indexing. So with that now we've reached the end of this video, and then in the next video we will go over my notes for mutability. So thanks for watching, and hopefully I will see you in the next video.